everyone, Katrina here, and today I'm going to show you how to find the distance between a point and a plane. Be sure to subscribe for more videos like these and stay tuned to watch the full example. Okay, so we're going to use this formula right over here to find the distance between a point and a plane. So this formula states that we want to take the magnitude between some vector p1, p2 with n, which is the normal. Okay, so let's kind of dive into this a little bit. So n is going to be the normal of the plane. So what is the normal of the plane? That's a vector that is perpendicular to the plane. And then vector p1, p2 is a vector formed between the point, I'll just say in question, which is going to be p1, and with p2, which is going to be a point on the plane. So we need this vector that's created, again, like you can see over here, that has the point in question, p1, and then p2, which is some point on the plane, and then n, which is the normal of the plane. And we know that n is any vector that is perpendicular to our plane. So let's go ahead and look at an example, and that way we can apply this equation in action so we can determine the distance between this point and our plane. So for our example, we want to see what is the distance between point 3, -2, and 0 with our plane, which has a scalar equation 4x minus y plus 8z equals to 2. So the first thing we want to figure out is what do we need to find? What else do we need before we can apply our equation? Well, in this case, we have our p1, but we don't have our vector p1, p2. So how can we find this? Well, this is where if we have 2 points, for example, if we were to have point 1 and point 2, then we could simply subtract them from each other in order to find our vector p1, p2. Okay? So how can we first find p2? So that is what is missing. So in order to find p2, we know that p2 is any point that exists on this plane. So we can just go through and see and find any point for x, y, and z that would render this equation true, such that the left-hand side will equal to the right-hand side. So let's try out a point. What if we have point, what if we say that, oops, sorry about that. What if we say that point P2 equals to -2, -2, and 1? What would we get in this case? We would have 4 times -2 minus -2 plus 8 times 1, and our right-hand side of the equation is 2. So does this equal each other? Well, we would end up with -8 plus 2 plus 8 equals to 2. So these would cancel out, and you end up with 2 equals to 2. So that's right. So that means that we can go ahead and use this point for P2. So now that we have a point for P2, we just have to create our vector P1, P2. So we need P1, P2. So we can just simply subtract them from each other. And what do we get? So we have P1 is 3, -2, 0. And then we have P2, which is -2, -2, and 1. So in this case, it doesn't really matter if we do P1 minus P2 or P2 minus P1. So if we do P1 minus P2, what do we get? We get some vector over here, which is equal to 5, 0, and -1. So we can now use this in our equation. So let's go ahead and plug this all into our distance formula. So distance here is going to be the magnitude of -5, 0, 1, and then with the dot product of our normal, which had we find our normal, we can just take the coefficients from our scalar equation. So we have 4, -1, and 8, and then we divide this by the magnitude of our normal again, which is, like we said, 4, -1, and 8. Okay, so now we have this all plugged in, so we just have to go through these operations. Okay, so let's start with, we'll just call this A and we'll call this B for the numerator and denominator. Let's start with A. So we have dot product here. So we just have to then multiply each element together and then add them across. So we're going to start with -5 times 4, and then we're going to add the next two. So we now are going to multiply 0 with -1. So plus 0 times -1, and then plus the third positional arguments, which would be here 1 and 8. So plus 1 times 8. Okay, so what does this give us? This gives us -20 plus 8. Okay, and then remember we still have our absolute value signs around this. So again, this would be -20 plus 8, which is -12. And since we have the absolute value signs, this is equal to 12. Okay, let's solve for our denominator now. So here we want to find the magnitude of a vector. So we can use the magnitude formula such that we can take the square root of each term squared. So we have 4 squared plus -1 squared plus 8 squared. So we're taking each element in our vector, adding them together, and squaring each one. So what does this give us? This gives us root of 81, and root of 81 equals to 9. So let's go ahead and put this all together. So if we do that, we see that D equals to 12 over 9, which can be simplified to 4 over 3 units. And that is our distance between our point P1 and our plane. I hope you enjoyed this video. If you did, please drop a like and comment any questions that you have, and definitely subscribe for more fun math videos. I have plenty more videos about vectors coming your way, so I'll see you next time.